attend to this question that we have on the board. We are still under the formation of differential equation, and this is going to be the last equation or the last question I'm going to solve on this particular topic under formation of differential equation. But then we are asked to use the hyperbolic function to form a differential equation, and that hyperbolic function is y equal to a cos ln x plus b sin ln x. Why do we call it a hyperbolic function? Look at what they are carrying. They are carrying h and they are carrying what? H. Whenever you see cos or you see sin or you see tan, like from the cos, sine and tan, whenever h is included, that particular function has turned to what? A hyperbolic function. Now we are asked to use the hyperbolic function to form a differential equation. Now how many constants do we have here? We have two constants. You know our normal treatment. So solution. Now we are given y equal to a cos ln x plus b sin ln x. Now we are going to be differentiating twice due to the fact that we have the what? Two constants, which is a and what? B. Now by differentiating twice, we have that y prime is equal to, okay, let me do this for you. When you are differentiating cos, you are going to be having sin. There's no minus on that part. And when you are differentiating sin, you are going to be have what? Cos. But then this is a function of a function, because you are also going to be what? Differentiating ln x. And don't forget that I said that when you are differentiating ln x, you are going to be having what? 1 over x. So take note of all this. Now when you differentiate this, you are going to be having a sin ln x. And when you differentiate ln x, you are going to be having 1 over x. So if you multiply this by 1 over x, you have it to be like this, over x plus b sin ln x. You are going to be having b cos ln x all over x, because you are also going to differentiating ln x, which is 1 over x. This is what you have. Now if you undergo another differentiation, you're not going to be using chain rule to do this again, because that will lead you to what? A quotient rule, and you know how to solve quotient rule. But for us not to undergo that particular stress, we are going to be multiplying through by what? X, so that at the end we will either use chain rule or what? Product rule. This is what I mean. You multiply through by 2. When you multiply through by 2, we are going to be having, you multiply through by x. You multiply through by x, they are going to be having this. X times y prime, you have x y prime equal to, when x multiply what we have here, that x will cancel the x on the denominator. You will be left with a sin ln x plus, when x multiply what we have on this particular place, the x will cancel the one on the denominator, and you will be left with only this function, which is b cos ln x. So that is that. Now we have to undergo another differentiation, because we have two arbitrary constants. Now to undergo another differentiation, we have two terms here, x y prime and then we have to involve what we call a product rule. So for you to differentiate this, you have to use product rule to differentiate. Now, if you are using the product rule, this is what you are going to follow, or the particular process you are going to follow. Now, you have here to be, you keep one of these and differentiate the other one, and then you keep the one you differentiated and differentiate another one. So to cut it short, you keep x constant and then differentiate y prime. If you differentiate y prime, you are going to be having y prime prime. And then you add there, you add. Now, which one did you differentiate? You differentiated this one. Keep that one constant. And then differentiate x. You are having what? 1. You have done product there, or you have used product rule to differentiate x, y prime. So this is what you have. Equal to, let us now undergo the same process that you undergone at this particular point. Now, if you differentiate a sin ln x, you are going to be having a cos ln x all over x, because you are still going to differentiate ln x as I did here, plus when you differentiate cos ln x, you have b sin ln x all over what? X. And then what are we going to do again? Let us multiply through by x. So when you multiply through by x, you are going to be having here multiply by x, this place multiply by x, and other things here multiply by what? X. So x times x y prime prime, you'll be having x square y prime prime. X times y prime times 1 will give us y prime. So x times y prime, you'll be having xy prime equal to x multiplied by everything that you have here. That x will cancel the x on the denominator. You will have a cos ln x. X multiplied by everything that you have here. That x will cancel the x on the denominator. You will now have plus b sin ln x. Now this is where we have reached. Now x square y prime prime plus xy prime. Now we have a cos ln x plus b sin ln x. Now let us look at the first solution. We have a cos ln x plus b sin ln x, which is the same thing as what we have here. So we want to eliminate our constant, and it is easy for us to eliminate our constant because we have a variable which is equal to what? The value that we have here, in which the constant is what? Included. And that variable or that function is what? Y. So you have it to be equal to what? Equal to y. So you can see you have eliminated your constant using that particular step on that particular approach which I have used. Now you have your final answer to be x square y prime prime plus x y prime minus y to be equal to what? 0. So this is what we have used our hyperbolic function to form a differential equation. So this is the last example I'm going to solve on this topic, or that I've solved on this topic. I'm sure that you have undergone or you've understood this particular topic to its what? Very best. Please don't forget to like, comment, share, and subscribe to this video. Thank you for watching. I remain your humble tutor, Instructor Victor.